Hello everyone, I am Bradley Sward, Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And this video today is going to take a look at x86 assembly language, something we would cover in Chapter 6 of the Kip Irvine textbook that we have. So basically, this chapter is looking at selection statements, otherwise known as if statements. So this video is going to take a look at 3 separate examples of how to go about doing that. So example 1 here is the word problem approach to what I want to do for problem 1 here. And so I'm saying they're going to be very similar. So once we get going, once we kind of get the groundwork going, we can change what we need to change. But we go enter a value. I want to print that out. I want to then prompt the user for input. And then very simple if statement. If the value is greater than 27, do something, print something, and if it's less than or equal to 27, print something else. And then print an endline character and then pause the program so we can see the results on the screen. So, so it's more of pseudocode than a word problem, but it's what we're going to do here. So if you want to pause right here, because in a second I'm going to take you over to my C++ code, and then we're going to transfer it over and translate it into assembly. 1, 2, 3. Okay, so here is my working example C++ code. I have 3 global variables, one for each of the strings that I'm going to be printing out. And then I have a register. Again, it's not 100% translation between the two, but I'm going to use a register, EAX. And then print out input into the EAX register, and then do my comparison check and print everything out. So again, if you need help getting Irvine library up and running, that is not the point of this video. This presumes you already have the Irvine library going. So over here is where I have everything. So if I just kind of input byte, enter a value, count 0, and then I've got larger byte. I'll just simplify it here. Greater than 27, just to save you all that extra watching me. And then smaller. Less than or equal to. So those are my 3 strings, of course, that I'm going to be using. I think they're all good. If not, the assembler will tell me later. So then I want to print the input out. And of course, we start, get used to this here kind of thing. We move into the EDX register, the offset of the input variable, which is the enter value string, call write string. So just to get things going, and just to make sure we have the basics going, here is my program, and there is my enter a value string. So good, I'm already on my way here. And so the next step of cinning and this call read int. And so this read int will take whatever the user inputs and put it into the EAX register for me. That's pretty much a done deal given. So if I just to show this, if I do call read int and then call dump regs, we'll see. At least it'll be in hex. I'll put 14 in hex. Oh, no, make it easy on us. I'll put 7 in hex. And so here you go. You can see the EAX register holds the 7. So, and then the dump regs just prints out all the contents of my register. So yep, read int does what I'm expecting it to do, which is great. So I can get rid of this. And I'm just going to finish this down here. The last 2 lines of code, call CRLF and call wait message. So this is the cout end line, and this is the system pause. And then we always need the exit. That's like a return 0 from our main here. Okay, so now continuing on, I have my input, right? I'm just kind of breaking it up. I have my output. There's my cout. There's my cout. There's my cin. And now it's just a matter of doing the if statement. And example 1 is already done. So every if statement breaks down into 2 separate lines of assembly language code. The first line is always some kind of comparison, and it's whatever that kind is the next line of code. It's always the same thing. Compare EAX to 27. And so what I need to do here is I need to go code branching. So I need a label of some sort. And so let's see, I'll call it larger here. And so what I'll say here is if greater than. So that means if EAX is greater than 27, what I like to kind of visualize in my head is the JG. The G means greater than, so think of a greater than symbol, and move it over and replace the comma. So compare, so if EAX is greater than 27, I'm going to jump to larger. And if not, and if it's false, fall through, what is the case that makes that fall through? That is, if jump of greater is not true, which means then it would be less than or equal to. And then if that's the case, I could move into the EDX register offset of smaller. And then call write string. And then I could do the same thing for here, and I could say, but instead here, put in the larger one. And you're like, okay, I mean, it is missing one little thing. I'll tell you that right now. I know that. I'm not just, uh-oh, I have an error somewhere. 1 second here. Oh, okay. Invalid operand size for instruction. And that's just because I have, in my haste here, I have a variable called larger, and I have a label called larger. So let me just make it large and small down here. Oops, I'm sorry, I need that. So I only have the one label, so I'll call it large instead. Okay, there we go. So I go enter a value, and I go 28. And now here's the interest. It prints greater than 27, so you're like, oh, okay, I'm done testing, right? Well, now you get an 80% instead of a 100 because it worked for your one test, but what if I put 27 in? And it prints, oh goodness, less than or equal to 27 and greater than 27. And why is that? And that's because when I compare EAX to 27, and if I do jump if greater of large, again, if it falls through, that means that this was a false statement. And what does that do? It prints out the less than or equal to 27, which is what we want. However, we will still continue to fall through the code. So then it goes down to here next. I mean, there's no code to tell it to do otherwise, and it will print out the larger string right after. So I like to do something kind of like done or something like this. Like if this is all said and done, literally, figuratively, I like to do an unconditional jump to done. So that'll go right around everything. So now it'll print this and come to here. So it only prints one thing, or it goes to here, prints one thing, and we're done. So now example 1 should be complete. So again, 28 will print just greater than 27. 27, I hate doing this every time, dragging it over. 27 gives me less than or equal to 27, but nothing else, which is good. And then, my other fringe case, what is it, 26 maybe? They're less than or equal to 27. So good. That is example 1. This is the complete example 1 for what I'm trying to do for this kind of stuff here. And so pretty simple, just you got to get used to the thought to with any jump statement, any condition, you have to have labels, and a lot of times you have to have a lot of them, and we'll see in the next couple examples too, or at least the next example. It's a little more involved, just a couple more if-elses. Okay, so moving on, problem 2 then. So let's translate as variations of a theme here. So I will enter a value, get the input value. This time let's get it unsigned. We'll try, the signed versus unsigned only really plays a role when we deal with which jumps do we use, because the first example had signed jumps, so then we use a greater than or less than. But when we're dealing with unsigned, we'll see that we'll use above and below when it comes to the code. We'll test that out as well. Okay, so enter a value, and if it's a single digit value, tell the user it's a single digit value. If it's a 2-digit, tell them. If it's a 3-digit, tell them. Otherwise, tell them it's 4 or more digits. We're not going to go absolutely crazy on this, but just go how many digits are in this number and tell me, and then print the end line and pause. So I have some of this already going, right? So like asking the user for input, all this stuff in the middle kind of is no longer needed here, but just to kind of bring us back, just to make sure we're right back where we are. There's my enter a value, and now I have my prompt, and I'll read the input in. So then the EAX register holds the value that I'm expecting, which is good. So let's try it out. Okay, so compare EAX register to 10. Jump if, okay, so now we're dealing with this is unsigned values, so we have to watch out for this because we're using greater than or less than before. So just look through your slides, look through your PowerPoints. For unsigned values, I have to use JB for jump if below, which is the same as jump if less than. It's just the unsigned version of that comparison. So then jump if below. So this means if EAX is less than 10, I'm going to move. Here, let me put a done down here. Done label. Move into the EDX register. Oops. Oh, jump if below. Go to, I'll call it print 1 for print 1-digit number. Sorry about that. Okay, so then, and we'll just set everything up and then we'll kind of fall in line here. So then now we just do another comparison to 100 and say, okay, so this will handle all the 2-digit numbers. So like, okay, I'll go to print 2 if that's the case. And so then 3-digit. And if we fall all the way through, then it's got to be 4 or more. So let me find my C++ code here so I can take a look. I can't just go and steal it, so I'll just print out. I'll just create some real fast here. 1-digit. Two, 3, 4, 1-digit, 2-digit, 3-digit, lots of digits. Okay, so I've got my 4 strings now, 1, 2, 3, 4. And so if I fall all the way through this, it's not a 1-digit number, it's not a 2-digit number, it's not a 3-digit number. So I can move into the EDX register, the offset of 4, and do my print call write string. And remember, we got to make sure we go through all these labels, go all the way around them. So we have to do an unconditional jump to done when this is all said and done. But otherwise, we can kind of steal this code for the others, and just instead of just put in 1, and then write the string jump around. And then for this, send in 2, jump around, go to 3, jump around, and then this one, technically you don't need it, right? Because this is the final one, print 3, and you're like, jump to done. And it's doing the same exact thing as if I just fell through. So you don't necessarily have to have that final jump in there. And so it's a lot of code, but it's pretty much, it's pretty much all said and done. Print 1, jump, print 2, jump, print 3, fall through, and then here's my print 4 if I need it. So let's try it out. Enter a value. So 9, 1 digits. Oh, fix that up. Enter a value 10. Gives me 2 digits. Say all the test cases, right? So just to make sure I did everything right. 99, 2 digits. Should put a loop in there, but oh well, I didn't do that. And then put another one, 100, 3 digits. Good. 2 more times to run this, or a couple more times. 999 is 3 digits. And then anything more than that, 1000, lots of digits. So again, because this is unsigned, what happens if I put in a -1? I get lots of digits, because as an unsigned value, -1 as an integer value is 4.29 billion. So 4.29 billion is lots of digits. Like it's the definition of lots of digits, 12 or 14 or 15 or whatever the number is. So, or whatever it is. So that worked for us. Otherwise, what would -1 be? I don't know, and I don't necessarily care to find out. But this, if, else, because I see the else at the end of this, I know I go down exactly one code path no matter what. And this is one way to go about doing it. I go down this code path for 4, or this for 1, or this for 2, or this for 3. So remember, if you don't see an else, you don't always have to go down a code path. If I see an if, I can go down 0 or 1. If I see if, else if, I can go down 0 or 1. If I see if and I see an else, I've seen if, an else if, but if I see an else, I know that I have to go down exactly one code path with this selection structure. So, okay, so that's problem 2, just solving there. So I don't think I can get it all on, I can get it all on one, itchy nose here. I can get it all on one page for you. So then problem 3 now, let's do all of this and kind of use a function. Let's kind of combine everything that we've done from chapters 4, 5, and 6 into one problem here. So let me get rid of all the superfluous stuff that we've already done, and we're ready to get started. Let me just make sure, enter a value, 55. Okay, so I have that. So I'm doing the same exact thing a third time here. So this problem, enter a value, put a value in, and so I'm going to create a function called isPositive, and this does exactly as you expect. It's essentially a Boolean function that's going to return a 1 if the value that I input is positive and a 0 if it's negative. Because it is positive. Is it positive? Yes or no? True or false? Yes or no? So if the value is positive, tell the user it's positive. Otherwise, tell the user it's negative. And all the other things apply here. So again, I broke this down and wrote some C++ code that handles our situation here. So we're kind of ready to kind of break this down. And we can, what do we want to do first? Let's, I'm just going to write the function first. So is positive proc. Oh, I can make this a little bigger now. Where's my mouse? There it is. Is positive proc, is positive np, put a ret. Remember that, again, the difference, an exit is an immediate close of your program altogether, and ret is a return from a function to some other, whoever called it. Huge difference here. And we're going to cover that in much more detail when we get to chapter 8, gosh, in a few weeks here. So, okay, so what is my goal here? I say here my EAX is going to be my input, and it's going to be my value to check. And then also, my output is going to be EAX. 1 if positive, else 0. So again, this kind of stuff you have to tell, like this is your API, you have to tell anyone using your code, including yourself, when you come back to this later on, like, what does this function do? Because you're not going to look at that code. I mean, this is simple enough code, but for any program of any worth, you're not going to have any idea what it's doing. So you need the documentation. You got to have it. You're not going to reverse engineer this thing all the time. Okay, so what do I want to do? This is definitely signed no matter what, because positive, negative, right? You cannot have a signed or an unsigned value with a negative in it. It's just impossible. So this just comes straight up to comparison. Compare EAX to 0, right? Because I want to, if the value is less than 0, it's negative. Otherwise, it's greater than 0. So, okay, so I want to do a jump because I got to do some kind of jump. And so I can pick whatever one here. I just want to say, since this is signed, again, I got to use the less than, JL. And we can test it out just to make sure. JL, I want to jump to, let's just say negative. And sometimes what I like to do, even though you don't have to do it, is I put in an extra label, I'm almost like a comment. Be like, okay, this means I'm in the positive section here, because if it's not less than 0 and I fall through, it has to be greater than or equal to 0. So then what I can do here is just move 0 into the EAX register. I'm sorry, move a 1 into the EAX register because it is positive, and then do my jump to done, which I don't have the label just yet. Done. So I mean that takes you down the 1 code branch, right? This is the return 1 essentially. So compare. If it's a positive value, it'll fall through, or 0. 0 is a positive value. It sets EAX to 1, comes around, and then returns. Otherwise, what do I want to do, right? I want to set EAX to 0, and then fall through to done, and I'm done. And so the final thing here is just making sure the final rule of this is always, did I blow out any registers but EAX? And in this case, the answer is no. All I did was tinker with EAX, but if anything else is modified, I have to do my pushes and my pops in front and at the end, respectively, to this function, because again, my workspace has to be put back. Everything I promised I would blow out will be blown out, but anything that I didn't mention in my commenting needs to be put back to how it was prior to starting the function. That's just our contract as a programmer in x86 assembly language. Okay, so the function itself is pretty much set. So let's see what we've got here. So I can call readInt. EAX is holding my integer value, and the EAX, surprise, surprise, is my input. So I don't have to do any extra work. I can go right into calling my isPositive function, which is awesome, right? Like if my value was stored in a different register, or my value was stored in a variable somewhere, yes, I would have to go and pull in and move this thing into the EAX register before calling. But because this function is working for me very nicely, I don't have to go ahead and do that. So isPositive takes EAX as the parameter, passes it in, EAX comes back. So now, say like this is, the function itself should not do any of the printing. because it's just a function, it's just returning a true-false bool value. It's on me, on the main side, to take that and do what I need to do with it, which is just now compare EAX to 0 and say if jump if equal. So that means if, it depends on how you want to look at it. Let's compare to 1. And then so I'll say is positive. Because if I compare to 1 and they're equal, then yes, it came back. It is positive. So you're almost duplicating the code from earlier. And again, if you feel good about it, if you want to, you don't have to, but I like to do put an is negative here, even though you're never ever jumping to the thing. But in this case, I want to move into the EDX register the offset of, I'll just say P for positive, call write string, and jump to done. And so let me set up these, let's say, all over the place kind of thing here. I'm going to make this a little smaller since we're getting there. So I say P, byte, positive, comma 0, and then N, byte, negative, comma 0. So if it's, oops, put an N there, sorry, coming back. So if it's negative, put the negative string in, call the write string, jump around to done. Otherwise, put the positive string in and write string, and then I don't need to jump because I'm falling right into done. So let's see, with all of this, let's see if I can get this all on 1. There we go. So let's try it out. Different values. Oops. Oh, I have an error. What's my error? Oh, is positive. Oh, because I'll say is pos. Because the name of that is coincidentally is the same name as the function name up above. I'm famous for that, and I don't have to change. Oh, is pos. Jump if equal to is pos. And you'll see this. It gets hard because you're going to have a ton of labels, and the labels can't match the variable names, can't match the function names. It does get challenging after a while because every name has to be unique. Okay, there we go. So let me drag this down so we can see everything again now. And then now enter a value. I say, okay, 1 comes back positive. 0 comes back positive. Negative 1 comes back negative. And that's what I'm expecting to see. Because what would happen, just to say, what would happen if I change this JL to a JB? Jump it below. This negative 1 would now be positive because that's doing an unsigned if statement, an unsigned comparison. And so negative 1 is actually max int, right? It's 4.29 billion. So, it's never going to be below 0. So I have to make sure I use the correct jump in every situation. And usually the compiler knows what it's doing, does it for us, but as us here at this low level, it's on us to do that work. Let's see. So last thing, you can do this for the other examples as well. It's just a slight little bit of refactoring here at the end, is that I have this call write string in both. Like I'm changing, the offset of N is going to EDX or the offset of P is going to EDX, but in both cases, I'm calling write string. So what I could do, just to simplify my code a little bit, is I can hack this thing out of here and bring it down to done. So because now it'll set N, it'll jump to done, and then it'll call write string. It'll set P, fall through, and call write string. So I don't have to duplicate the effect of having to call write string, especially if I had this 5-6 times over, like the second example, the previous example we did here today. Like I could remove a write string for all but one of, because I need to at least call it one time, but I can reduce it down and reduce my code base. So when I do that, I better check it out again, right? Check my 99 is positive. 1 is positive. 0 is positive. And then basically if I get negative 1 is negative, I've done my job. Okay, so that covers the basics of just getting simple jump statements, simple comparisons going, 3 separate examples, and we used function. So as always, thanks for sticking with this. If you have any questions, send me a comment, send me an email, get a hold of me some way, and I will get back to you. We'll be looking forward to more videos in the future. Thanks, guys. Have a good one.